Hey, what is up guys? Welcome to another video. In this video I'm going to be going over the first paper of the Maths GCSE resits. So these are for the people that failed their maths exams. They can come back in November and do a resit of that exam. This is the first paper, the non-calculated paper, sat on the 2nd of November 2017. This is the official Edexcel exam that they sat in November. And I'm going to be going through the whole thing in this video. These people sitting this exam were given 1 hour and 30 minutes. I'm hoping to cover all of the questions in about that time. Just before I start, I have linked this paper in the description. So if you haven't done this paper yet, I'd suggest having a go before you actually watch this video. So have a go. And then as we go through, you can mark what you have done yourself and check your understanding to see how you went. So there's really no point watching this video unless you've done the paper already. Okay. And as I said, that's in the description. If you need the paper and you can't find it, I've linked it down below so you can go ahead and it's just a Google Drive file. You can download, print that off and have a go at it yourself. And that's a really good revision. So without further ado, let's get started. Okay, question 1. Question 1 is a prime factors question, and this should be bread and butter for students sitting this exam. So it says write 36 as a product of prime factors, and it says it's out of 2 marks, so you probably need some method to show you're working and also the answer. So you could use a factor tree and split 36 into its prime factors, and you can start with, for example, 4 and 9, and then 4 is 2 squared and 9 is 3 squared, and they are both prime numbers, so your answer here is going to be 3 squared times 2 squared equals 36. Okay, question 2 says Kiara is 7 years older than Jay. Martha is twice as old as Kiara. The sum of that 3 ages is 77. Find the ratio of Jay's age to Kiara's age to Martha's age. Okay, so we're given some relationships here. Usually when you're given statements with relationships, you need to use algebra in order to relate those things. So we can say that Jay's age, we can say give it a value such as x, and then we can say Kiara's age is 7 years older than Jay, so that's going to be x plus 7, and then Martha's age is twice as old as Kiara. So how can we write twice as old? We can multiply it by 2, and a better way to write that is 2 bracket x plus 7. Okay, so I hope you can see how I've related those 3 ages. And then finally we're told that the sum of those 3 ages is 77. So what I can do is I can take Jay's age, I can add it to Kiara's age, and then I can add it to Martha's age, and all of that equals 77, and in the end I have one equation with one unknown which I'm able to solve. So let's simplify a little bit first. So over here I've got 2x plus 7, and then if I expand these brackets I've got 2x plus 14 equals 77, and then if I keep simplifying I end up with 4x plus 21 equals 77. And then 4x, if I minus that 21, I get 4x equals 56, and then x, 56 divided by 4 gives you 14. Now that hasn't finished the question just yet, because I need the ratio of their ages. So because x is 14, I know Jay's age will be 14. And Kiara's age is 14 plus 7, or x plus 7. So that's going to be 21. And then Martha's, if I plug 14 in here to this equation, I get 42. So actually the ratio of their ages is 14 to 21 to 42. And you could go ahead and simplify that, but because their ages, they can stay as their actual values. So because we actually want to know what Jay's age is and we want to know what Kiara's age is, we can leave that as 14 to 21 to 42. Okay. So question 3 gives you a diagram and it says ABCD is a parallelogram, EDC is a straight line, this one here, F is the point on AD, so that BFE is a straight line, angle EFD equals 35, angle DCB equals 75, show that angle ABF equals 70 degrees, give a reason for each stage of your working. Okay, so angle ABF is in here. And we need to show that that angle equals 70 degrees. Okay, so we're told that this is a parallelogram, and generally there are a few ways to approach these types of questions because you can find all sorts of different angles in here. You could find this one because it's opposite angles in a parallelogram are equal. You could find this one in here because they're vertically opposite. There's a range of approaches you can take here, and I am going to go with co-interior angles of parallel lines. And I've actually made a video on parallel lines going through the different angles that you can find in parallel lines, and one of them are called co-interior or interior angles. And what that postulate says is that interior angles of parallel lines add up to 180. So we can say that angle DCB plus angle ABC equals 180 degrees. So we can say co-interior. And that's all you need to write for a reason, because that shows you're understanding the process. So then we can say, because they need to add up to 180, this angle in here, angle ABC, must equal 180 take 75, that's going to be 105 degrees. And if that is 105 degrees, we can figure out what these two angles are. So the first step towards that I would do is to say that this angle is, so AFB, angle AFB equals 35, as it is vertically opposite. And as long as you get these terms correct in here, that's all you need to write in those brackets. So up here that's 35 degrees, and therefore angle FBC equals 35, as that is an alternate angle. Alternate. Again, if you're not understanding these co-interior and alternate terms, watch my video on parallel lines. And so therefore we know that angle ABC is 105, and we know that angle FBC is 35. So therefore angle ABF must equal 105 take 35, which equals 70 degrees. Okay, so that's one way of proving that angle ABF equals 70 degrees. Okay, question 4 says the diagram shows a logo made from 3 circles. Each circle has center 0. Daisy says that exactly 1/3 of the logo is shaded. Is Daisy correct? You must show all your working. Okay, so you can see that this middle area is shaded, and there's a big area on the outside unshaded and a circle in the middle unshaded. And we need to show whether this shaded area is a third of the whole thing or not. I'd say it's going to be pretty close, but let's find out if it's actually exactly a third as Daisy says. So the first thing we need is the area of a circle, something that you need memorized. So the area of a circle is pi r squared, where r is the radius. So what I'm going to go ahead and do is, because we're given these distances here, we know the radius for each circle in this logo. So in this logo we've got three separate circles. We've got this big circle, this medium circle, and this small circle. So I'm going to go ahead and find the areas for each of those and then see how we can work out what the area of this shaded region is. So the area of the big circle is going to be pi times the radius squared. Now the radius here for this big circle on the outside is going to be 4 plus 3 plus 3, so that's 10. So the radius squared, 10 squared, is going to be 100 times pi. So the area of that big circle is 100 pi. Now the medium circle, the area of that medium circle is going to be 7 squared times pi. 7 squared is 49 pi, and then the small circle is going to be 4 squared times pi, so that's 16 pi. Okay, so we have all of our areas. So is there a way that we can find the shaded area using the areas that we have found? Well, yeah, there is, isn't there? We can subtract this small circle from the medium circle, and that should give us the shaded area. So we can say shaded area equals the medium circle, 49 pi, subtract the small circle, 16 pi. And by the way, if you ever get questions about areas of circles in a non-calculator paper, it's usually better off to leave pi as is rather than trying to work this out. Rather than try to calculate this number, just leave it as 100 pi, etc. So 49 take 16, that's going to be 33 pi and centimeters squared. Okay, so we know the area of the shaded region. The area of the whole logo was the area of this big circle. So the whole logo has an area of 100 pi. The shaded region is 33 pi. So while that's very close, it's not exactly a third. So, and then you need to state this in a sentence. So you could say something like, no, 33 over 100 does not equal a third or something. So Daisy is not correct. Okay, so that's question 4. Question 5 says the table shows information about the weekly earnings of 20 people who work in a shop. And here we're given a table with their weekly earnings, and this is continuous data, and then the frequencies, and it says work out an estimate for the mean of the weekly earnings. Okay, so when you're given continuous data and you're asked for an estimate of the mean, that means you need to find midpoints and then approximations for these totals. So let me show you what I mean here. If you haven't done this process before, this is something that you do need to learn. It is important. And while it might, as I said, if you haven't seen it before, it might look complicated, it's actually not too bad. So we know that 20 people work in the shop. So that total of the frequencies must be 20. Here we need to find the midpoints of these ranges. The reasoning behind this is that we have one person in here that's earned between 150 and 250 pounds. And we don't know exactly how much that person has earned. So to work out an estimate for the mean, we need to guess that that person earned about 200. So the midpoint of this range of 200. And then what we go ahead and do to work out how much they earned in total, we say 1 times 200, and we get the total of 200. So here we've got 11 people earning between 250 and 350. So we estimate that they earned about 300 each, and then we multiply that by 11, and we get 3,300 for our estimate there. We go ahead and do that for each range, and then we tally, we total those, and we can find the estimate for the mean. And the last one is, the midpoint is 600. So the total is 1800, and then we add all of these up. If you add all of those up, you get 7,300. And what we want to do now is, when you're taking a normal mean, you add all of the totals up and you divide by how many there are. So we can say that the estimated mean is going to be the total divided by 20. And if you do that calculation, you obviously have to do, because it's a non-calculated paper, I guess you could work it out without doing the working yourself. But if you do bus stop division, for example, you could say this is 3 and then 13, and then you get 365. So, oops, sorry for that I keep slipping. So once you work that out, you get an estimated mean of 365 pounds. Okay, and now after you get these results for an estimated mean, I always say do 2 checks. Check for is it realistic and is it reasonable. So the check for is it realistic is you check the minimum and the maximum values. It has to be in between those. It can't be less than the minimum and higher than the maximum. It's impossible. So is it between 150 and 650? Yes. So it's realistic. Is it reasonable? So if we look at the spread of this data, most people are between 250 and 350, so we'd expect the mean to be around there somewhere, and it's 365. So yes, it's reasonable as well. So once you've done those 2 checks, you should feel confident to move on. So part 2 says, Nadia says the mean may not be the best average to use to represent this information. The mean may not be the best average to use to represent this information. Do you agree with Nadia? You must justify your answer, and this is 1 mark, so you probably just need to write 1 sentence clarifying whether you agree or disagree and why. And I'd say with a mean, it's sometimes not the best if there are outliers in the data. So an outlier is a data value that's very different from the rest. So if you're talking about wages, if there is 20 people in the company earning £400 a week and there's one person earning £10,000 a week, that person earning 10,000 would be called an outlier. So in this data, I would say we do have outliers because we've got 3 people earning much more than the rest. So I would say Nadia, because she said may not be, I would say yes, I do agree, because there are outliers that could skew the data. So I'd say yes, as there are outliers that could skew the data. And that's probably all you need to write for 1 mark. I'd say the key word they're looking for there is outliers. Okay, question 6 says, here's a rectangle. All the measurements are in centimeters. The area of the rectangle is 48 centimeters squared. Show that y equals 3. Okay, so they're telling us y equals 3, and we know the area is 48 centimeters squared. And they've told us the length, or the width is y and the length is both 2x plus 6 and 5x minus 9. So if this is a rectangle, we can actually say straight away that these two sides equal each other. So 2x plus 6 equals 5x minus 9, as these sides must be equal. It's a rectangle. And then we can go ahead and solve for x here. So there's, rearrange this however you like. So 5x minus 2x, 3x, 6 plus 9 will be 15. So x must equal 5 there. And then we can say, well, taking one of these equations, let's say 2x plus 6 equals, if we substitute 5 in there, we get 16. And therefore, y times 16, in other words, the width times this side, 16, must be 48, must give the area. So then we can just simply solve for y here. So y equals 48 divided by 16, which is 3. And therefore, you've proved that y must equal 3. Okay, so that's 4 marks there. So that's as long as you get that first step, the rest of it really comes together quite easily. Okay, question 7 says, Brogan needs to draw the graph of y equals x squared plus 1. Here's our graph. Write down one thing that is wrong with Brogan's graph. And this is for 1 mark. So write down one thing wrong with this graph. So it's not a bad graph. There's one thing jumping out at me. She's labelled her axes. She's done her scale correctly. She's labelled the graph. Her points look accurate. But there's one thing jumping out at me, and I hope it's jumping out at you, is that she's ruled in the lines. And you just can't rule in the lines on a quadratic curve because it is a curve. It's not made up of straight lines. So I'd say that she hasn't sketched the curve. So the curve is not sketched. It is ruled. Curve should be, curves should be something along those lines. The curve should be sketched, shouldn't be ruled in. So as long as you got something like that, you should get 1 mark. So question 8 says, write these numbers in order of size. Start with the smallest number, and we're given 0.246 where the 4 and 6 are recurring, 0.246 where the 6 is recurring, 0.246 where all of the numbers are recurring, and 0.246 with no recurring decimals. So when you are asked to order reoccurring decimals, usually it only takes looking for the next digit in the number. And as long as you can find that, you can order these pretty effectively. So in this one, it's 0 because there are no recurring decimals. In this one, it's going to be 2. And the next digit in this is going to be 6 because the 6 is recurring, and in this one, it's going to be 4. And now we can see pretty easily that this is obviously the lowest because it's 0.2460. This is the next 0.2462, 0.264, 0.266. So as long as you find that next number, then you should be alright to order these. So 0.2, and make sure you draw in the recurring dots correctly in your answer. That's one way to lose simple marks. Okay, 2 marks for that question. Okay, question 9 says, James and Peter cycled along the same 50-kilometre route. James took 2.5 hours to cycle the 50 kilometres. Peter started to cycle 5 minutes after James started to cycle. Peter caught up with James when they had both cycled 15 kilometers. James and Peter both cycled at constant speeds. Work out Peter's speed. Okay. There's a very useful equation that keeps coming up in these GCSE exams. It is speed equals distance over time, and variations of this that help answer a lot of questions in these GCSEs. So if you memorize that, and it's quite easy, I think, to memorize, speed equals distance over time, you should be fine with all of these speed type of questions. So the first thing we can work out is James's speed, because we know he took 2.5 hours to cycle the 50 kilometers, and they both cycled at constant speeds. So his speed, so James's speed equals distance over time, and that's in hours and kilometers, so the answer is going to be in kilometers per hour. 50 divided by 2.5 is 20 kilometers an hour. So we know James's speed is 20 kilometers an hour. Next, we're told that Peter started to cycle 5 minutes after James started to cycle, and Peter caught up with James when they both cycled 15 kilometers. So after 15 kilometers, what we want to know is how far James has cycled. Sorry, not how far. We're told it's 15 kilometers. We want to know how long it took him. So again, using this equation, by rearranging it, we know that time equals distance over speed. So the distance was 15 and the speed was 20. James's speed is 20 kilometers an hour. And so that's obviously 3/4. So he has taken 0.75 hours to ride 15 kilometers. 0.75 hours is, well, think about it, what's 3/4 of an hour? We literally say that when we're talking about time, we say 3/4 of an hour is 45 minutes. Or you can just multiply that by 60, either way. So we know that after 15 kilometers, it's taken James 45 minutes at 20 kilometers an hour. We're trying to work out Peter's speed, and we know that Peter started to cycle 5 minutes after James started to cycle. So how long has he taken to ride 15 kilometers? Well, if he took off 5 minutes after James, then he's taken 40 minutes. So Peter took 40 mins to ride 15 kilometers. So now we know that Peter took 40 minutes to ride 15 kilometers. So we can say that the speed equals the distance over time, so 15 over 40. However, this is in minutes, and this is where it gets a little bit tricky to calculate, because obviously this is a non-calculator paper. So we need to change that into kilometers per hour. The way that I did this is that I changed 40 minutes. So if we divide that by 60, that changes it into hours, and this is if you simplify that, becomes 2/3. So 40 minutes is 2/3 of an hour. So this becomes 15 over 2/3, which becomes 45 over 2. Remember, if you divide by a fraction, you flip it and multiply. And then I can do 45 divided by 2 in my head easily enough, which is 22.5. Let me know if you used a different approach. How would you divide 15 by 40 and then change that into hours? Let me know. But I think this is this does the job. So I end up with a speed for Peter of 22.5 kilometers per hour. Okay, question 10 says, write down the value of 10.5, and this is evaluating whether you understand what numbers to the power of a fraction means, and hopefully you know that if something's the power of a half, this means the same thing as the square root of. So that's asking what is the square root of 100, which is 10. And then again here we've got, it says find the value of 125 to the power of 2/3. And what this means is we take the, the denominator, and that becomes the nth root. So this is the cubed root of 125. And it doesn't actually matter whether you put the squared inside the square root or the cubed root or outside of it. You will still get the same answer. So we can say, what is the cubed root of 125 squared? And this is going to be, hopefully you know your cubed roots and squares. If not, you can work it out pretty easily. That will be 5. The cube root of 125 is 5 squared, which is 25. So 2 marks for that one, as you need to kind of do a little bit of work. Question 11 says 3 teas and 2 coffees have a total cost of $7.80. 5 teas and 4 coffees have a total cost of $14.20. Work out the cost of 1 tea and 1 coffee. Here is a simultaneous equations question, and I would go ahead and use the standard approach to simultaneous equation questions. So firstly, write out your equations, which are given in the question. And then see which one we can eliminate, which unknown we can eliminate to solve. And here I would say that probably the quickest way is to multiply this equation by 2 in order to make sure that the unknowns are equal, and then I can eliminate one of those. So if I multiply equation 1 by 2, what I end up with is 6t plus 4c equals 1560. So hopefully you've done this before and you understand where I'm going with this. Now that I have made 2 of the unknowns equal, I can subtract those equations, and I end up with, actually it's going to be easier if I do it the other way around. So I subtract this equation here from this one. So let me just rewrite these again. So what we've actually done is, if we call this equation 1 and equation 2, this is equation 1 times 2, and this is equation 2. And what we're going to do is subtract those in order to eliminate one unknown. So we get t equals 1560 minus 1420 is 140. And actually we now know what 1 cup of tea costs. It's 140. And then if we substitute that back into one of these equations, let's say equation 1, if we substitute that back into equation 1, t equals 140, we get 420 plus 2c equals 780, and then minus that 420 from the other side, be 360, and then c equals 180, which, so C stands for coffee there. Okay, so tea is £140 and coffee is £180. I feel like I rushed through that a little bit. If you're not comfortable with solving simultaneous equations, I'd say that's definitely something you need to work on as well if you're not sure with some of the steps I took there. Okay, question 12 says the table shows information about the heights in centimeters of a group of year 11 girls. So here we've got the height in centimeters, and then we've got least height, median, lower quartile, interquartile range, and range. And then part A says draw a box plot for this information. Okay. And hopefully you see the word box plot and you are filled with confidence because you know exactly how to draw these. It's actually not difficult once you've done a number of them, because essentially all you're doing is plotting numbers on a graph. So we need, for a box plot, we need the minimum, the median, the maximum, the upper quartile and lower quartile. And here we're given 3 of those, and we actually need to figure out the others. So if I'm given the minimum and then the range, I can work out the maximum, because the range is the difference between the minimum and the maximum height. So the max is going to be 154 plus 20, so that's going to be 174. And then the upper quartile is going to be the lower quartile plus 7, so that's going to be 168. Okay, so we needed to actually use some working out there to find the maximum and the upper quartile. Once we've got all those values, we can go ahead and plot the box plot. So we can start at 154. Each of these is 1, I believe. Yes. 1, 2, 3, 4. Go ahead and plot that. And then the max is 174. Okay, the median is 165. The lower quartile 161. And the upper quartile 168. And there are all the values that we need for a box plot. So once you've drawn in all of the lines, draw in the box and the whiskers, and you are done. There's no need to label anything. Just draw the box plot and you're done. Okay, so there's 3 marks for you. So question 12 continues, and it says the box plot below shows information about the heights in centimeters of a group of year 11 girls. Oh, year 7 girls, sorry. Okay, so on this box plot we're given all of the information we're just given about the year 11 girls in the same way for the year 7 girls. And it says part B says compare the distribution of heights for the year 7 girls with the distribution of heights for the year 11 girls. Okay, so I would go ahead and write down some values. So the minimum equals 146. The lower quartile is 154 about. The median is 157 approximately. Upper quartile 165, and max about 170. Okay, so let's compare those to the year 11 girls. So let's say the median first, 157 versus 165. Okay, that's very different. So we need to kind of write these down on the same page, let's say, in order to see. So median. So what we could do is draw a little table perhaps. And with these types of questions, it's kind of up to you how you interpret, how you want to write the answer down. But as long as you have and I'll explain what the key information is in a minute. But a good place to start is actually writing down the values next to each other to show that you're actually comparing them. So the minimum for the year 11s, minimum for the year 11s was 154. Versus 146. The median was 165 versus 157. And the max was 170 versus 174. Okay, and you can make a table for all of those, the lower quartile and the upper quartiles included. So we could also work out a few things. We could say the range for year 7s. The range for the year 7s was 24. And the range for the year 11s was 20. And the interquartile range was 7 for the year 11s and 9 for the year 7s. Okay. So what can we say? On average, the year 11s are taller. On average, the year 11s are taller. And the spread is smaller, because the range versus the range of the year 7s is lower for each value. And you could probably say something about the minimum and the maximum. So for example, the maximum of the year 11s is higher and the minimum of the year 7s is shorter. And overall, that's what you'd expect as the year 11s are taller. But the key points in this question, I'd say, is to compare the values. So compare the median, say something about the average, which is the median, and say something about the spread. Okay, as long as you're talking about those things and comparing the two values. You could even say something as simple as the median for the year 11s is 165 and the median for the year 7s is 157. Therefore, on average, the year 11s are taller. And that would probably get you 2 marks. Okay, question 13 says a factory makes 450 pies every day. The pies are chicken pies or steak pies. Each day, Milo takes a sample of 15 pies to check. The proportion of the pies in his sample that are chicken is the same as the proportion of the pies made that day that are chicken. Okay, that makes sense. On Monday, Milo calculated that he needed exactly 4 chicken pies in his sample. Work out the total number of chicken pies that were made on Monday. Okay, so we know that in his sample he has 4 chicken pies. So in his sample the ratio would be 4 to 11, because we know there's 15 pies in the sample. And overall they made 450 pies. So in this ratio, what is one part of this ratio worth? Well, we can work that out by dividing 450 by 15. In other words, the total of this ratio is 15, so one part is going to be 450 divided by 15. 45 divided by 15 is 3, so that's going to be 30. And then 4 parts is going to be 30 times 4, which would be 120. So there are 120 chicken pies made on Monday. On Tuesday, the number of steak pies Milo needs in his sample is 6, correct to the nearest whole number. Milo takes at random a pie from the 450 pies made on Tuesday. Work out the lower bound of the probability that the pie is a steak pie. Okay, so there are a number of parts to this question. First is the number of steak pies is 6 correct to the nearest whole number? So what is the range of this that this could possibly be? So if it's rounded to the nearest whole number, it could be 5.5. So 6 is greater than or equal to 5.5, or it could be anything up to 6.5. So they're the lower and upper bounds of this value, this 6. And then it tells us Milo takes at random a pie from the 450 pies made on Tuesday, and we want to work out, well, firstly, what's the lower bound of the number of steak pies in total. So we know in the ratio is going to be 6 to 9, because we know he takes 15 pies every day. So there's going to be 9 chicken pies to 6 steak pies. So let's first work out how many total steak pies there are. So we can do that by, again, dividing 450 by 15. Well, this is kind of a repeat step actually. So we know that one part is in this ratio is 30. So we can say 6 lots of 30 is going to be 180. So there's around 180 steak pies made on Tuesday. 6 parts is worth 180 steak pies. But what's the lowest that this number could possibly be? Because he's rounded that 6 to the nearest whole number, and we want to know the lower bound. So we could do 30 times 5.5, and that will give us the lower bound of the steak pies. So 30 times 5 is 150, and half of 30 is 15. So 150 plus 15, that will be 165. And that's the lower bound. Okay. So we know the lower bound of the number of steak pies made on Tuesday. So the probability is going to be 165 out of the total. So the probability it picks the steak pie is 165 out of 450. And you can go ahead and simplify this by dividing by 5 and then by 5 again. And you get down to 7 over 18. But you don't actually have to simplify. You can leave it as 165 over 450 and you'll still get the 2 marks there. Okay, question 14 says the ratio y plus x to y minus x is equivalent to k to 1. Show that y equals x bracket k plus 1 bracket over k minus 1. The first time you read this question, you might start thinking, what the hell is this talking about? I have no idea. But then you start to break it down, and there's one key starting point that you need. If you didn't get this question, pause the video here and have a really good look at where you could start to start solving this, because that's the key step here. Is the starting point. Okay, so the starting point here is to realize that ratios can be written as fractions. So we can actually say that y plus x over y minus x, the same thing, is equal to k over 1. And I feel confident that as long as people are getting that first step, that they can solve this question. I'd say the hardest part is getting the starting point here. Once we've got that, we need to rearrange and then end up with this finishing point showing that y equals all of this. So, and rearranging algebraic fractions, I've done a video on algebraic fractions as well, if you're not confident with that topic, but rearranging algebraic fractions should be something that you're familiar with by year 11. Okay, so we can go ahead and cross multiply here. So on the left we'll end up with y plus x, and then on the right we'll have k bracket y minus x. And what we actually want to do is to get all of the x's and all of the y's on the same side. And what that will allow us to do is to factorize and then end up with the finished product, which is up here. So I want these y's on the same side and the x's on the same side. So I can add this kx over here. So I get kx plus x, and then minus this y over this side. So I get ky minus y. And you can see now if I factorize both sides, so I can take x out of here, and I can take y out of here. I'm very close now to my finished product, and all I need to do is divide this side by k minus 1. And I'll also flip this equation around, so I'll end up with y on this side, and I've divided this side by k minus 1. So I get x bracket k plus 1 over k minus 1, which is what I wanted. So I've clearly shown the steps I've taken. Don't skip too many steps here, because you're actually needing to kind of show the examiner the steps you're taking. They can't read your mind when they were marking these. Okay, so question 15 says x equals 0.436 and the 3 and the 6 are recurring. Prove algebraically that x can be written as 24 over 55, and there's a process to these types of questions, and I covered this in, I believe this was in paper 2 from June 2017. So I went over a question just like this one, and there is a process. So we start off by saying, as they've said, x equals 0.436 recurring. What we want to do is to multiply this by tens until we have the recurring part of the decimal equal. So if I multiply this by 10, I get 4.36 recurring. And then I need to multiply that by 100. So I get 1000x, and then I end up with 436.36 recurring. Hope you can see why I need to multiply that by 100, so that these parts of the decimal are the same. And what that allows us to do is to subtract this equation from this equation, and once I've done that, I will get rid of the recurring decimal part of the number. So what I end up with is 436.36 minus 4.36 recurring. And over here I've got 990x, and on this side we need to do 436 take 4, because essentially these parts cancel out. So I end up with 436 take 4, which is 432. So x equals 432 over 990. Oops, 990, and then we just need to simplify that. And well, one way to do that is divide by 2. So if we divide both by 2, we get 216 over 495. And then if you're a whiz at your calculating, you could figure out what the common factor is between these two numbers, or you could cheat a little bit and look at the first look at the answer that you need to get to, and is there a number we can multiply 24 by to get to 216? And if we pick 9 times 24 is actually 216. So what that actually does is check that 9 times 55 is also 495. Just to make sure you've got the right answer and the right working out. So 9 times 55 is 495, so that's provided a check on the rest of my working out. So now I'm confident that I've got the right answer and I can move on. Question 16 says y is directly proportional to the cube root of x. Y equals 1 and 1/6 when x equals 8. Find the value of y when x equals 64. So we're told that they're directly proportional. So what that does is that actually allows us to create an equation where if something is directly proportional, we can say y equals k cube root of x, where k is some unknown, that means that y will equal k cube root x. And we can find k by substituting these values into this equation. So when y is 1 and 1/6, actually I'm going to change that because I find it easier to work with improper fractions. When y is 7/6, x is 8. And the cube root of 8 is 2. So k is going to be 7/6 divided by 2, which is going to be 7/12. So therefore, y equals 7/12, substituting k back into this equation, cube root of x. So when x is 74, so y equals 7/12 cube root of 64, and the cube root of 64 is 4. 4 times 4 times 4 is 64. And then we just need to work that out, do some cancelling. So y equals 7/3. And there's 3 marks. Okay. Question 17 says, n is an integer, prove algebraically the sum of half n bracket n plus 1 and half n plus 1 n plus 2 is always a square number. Okay, so we can take these two equations and sum them together, and hopefully once we simplify that we get something that leads to a square number. So let's start off by writing this sum out. So we've got half n bracket n plus 1 plus a half, and I'm going to actually expand these brackets out in my first step. So using FOIL I can expand those brackets and say n squared plus 3n plus 2 equals, and what I get here is a half, and I should have expanded these ones out as well actually, n squared plus n plus a half n squared plus 3n plus 2. And well, let's just factorize this half out. So what we're going to get is a half, and then we can add the rest of the terms together. So n squared plus n squared is 2n squared, and then n plus 3n is 4n, and then I've got a plus 2 on the end. And because all these are all factors of 2, I can divide them all by 2. So this is going to be n squared. 2n squared divided by 2 is n squared, plus 2n plus 1. And what can I do with this quadratic here? Well, I can actually factorize that into two brackets. So n squared plus 2n plus 1. I need to find two factors of 1 that add to 2. Well, that's pretty simple because of the only factors of 1 are 1 and 1, and they add to 2. So this becomes n plus 1 times n plus 1, which we can write as n plus 1 squared, which by definition is a square number. So we have just proven that the sum of these two expressions is always a square number. It's actually pretty interesting. If you have a look at these expressions carefully and you experiment with them, it leads to some interesting topics. So if you want to have a closer look, if you want to get involved in some of these questions, they actually present some pretty interesting topics. Anyway, on to question 18. It gives us a graph. Might have to zoom out a little bit here. It gives us a graph, and it says enlarge shape P by scale factor -1/2 with the center of enlargement 0, 0. Label your image Q. Okay, so center of enlargement is 0, 0. This is a basic skills testing question where you need to understand how to enlarge something by a negative scale factor. So if it was just 1/2, we could reduce this shape by 1/2 with the center of enlargement, but because it's a negative enlargement, what we need to do is go through the center of enlargement, to the other side. So in effect, we're kind of going through a lens in a way. So first thing you need to do is draw in your lines. Draw in the lines that allow us to find where to enlarge the shape to. By the way, you don't have to do this. You can work it out without drawing these lines, but I find it helpful as a check in a way to make sure the answer is correct. So let's start off with this first point on the shape P. This is at 2, 3. So if I enlarge that by 1/2, by -1/2, I need to halve both of those and then they become negative. So 1/2 of 2 is 1, so -1, and then 1/2 of 3 is -1.5. So that point is going to be here, right on that line, as it should be. This point here is 2, 7. So 1/2 of 7 is -3.5, and 1/2 of 2 is -1. So that point's going to end up here. And then this point here is 3, 4. So 1/2 of 3 on the y-axis is -1.5 down here on the y-axis. And then 1/2 of 4 on the x-axis is -2 on the x-axis, on the other side of the center of enlargement. So now I've got my 3 points. I can draw in my enlargement. By the way, we still call it an enlargement, even though it's got smaller. We still call it an enlargement, and that's what it should look like. So you can see it actually flips over when you do a negative enlargement, kind of like it's going through a lens, and we need to label that Q. Okay, so that's 2 marks. Question 19 says, it gives us a diagram, and it says A, B, C, D is a rectangle. A, E, and B are points on the straight line L with the equation x plus 2y equals 12. Okay, so L is x plus 2y equals 12, and that's a straight line. And A and D are points on the straight line M. AE equals EB. Okay, find an equation for M. Okay, as the first thing we need the first thing I would do is to rearrange this equation so it's in slope-intercept form. What that means is I rearrange it so that it's y equals something. So this is actually going to be y equals, and if I divide everything by 1/2, it's going to be y equals minus x on 2 plus 6. So that's just that equation rearranged. And because we're told that A, B, C, D is a rectangle, we know that all of these lines meet at 90-degree angles. So we know that L and M meet at 90-degree angles. And you should hopefully know a fact about perpendicular lines, or lines at 90 degrees, and their slopes. So the slope of M is going to be the negative reciprocal of the slope of L. And the slope of L is given by -1/2 from this equation. So the slope of n is going to be the negative reciprocal of -1/2, which is 2. So that's the negative reciprocal. And look that up if you're not sure what that means. So we know the slope of m. So the equation of m is going to be, so the equation of m is going to be, so far, y equals 2x plus c. Now we don't know what the y-intercept is yet, but we know sum of that equation, y equals 2x plus c. Now, we can find E, because if E is the y-intercept of L, if y equals 2, so if x equals 2, y equals 6. So the y-intercept here must be 0, 6. And if we know the slope, of L, we can find the point A by finding B. So B is the x-intercept. Now, one thing I don't like about this question is they don't tell us that B is the x-intercept or that E is the y-intercept. And that is, so if B was not the x-intercept, this would change the question, but we kind of have to assume that is the case, which I don't really like. But anyway, assuming B is the x-intercept, B is going to be the point 12, 0. If y was 0 here, x would equal 12. So we can see a distance between these points going up by 6 and across 12. So if we go across 12 here and up by 6, this point A is going to be -12, 12. So point A equals -12, 12. Hopefully you can see how I got to there. And using that point, we can substitute it into this equation of m to find c. So we can say that 12 equals 2 bracket, my apologies, not 24, bracket 12 plus c. Therefore, c equals 12 plus 24 will be 36. So therefore, the equation of m is y equals 2x plus 36. And I know that sometimes this can be quite a difficult topic, specifically, well, I think finding the slope of m would not be difficult, but there's quite a few steps in this question, and one of the steps that I think a lot of students have trouble with is firstly starting off with the equation of m and then putting in c as a placeholder or an unknown and then using a point to find c. And that's a tricky concept to get your head around, and it's a difficult topic, but I honestly believe if you do enough practice, then you definitely get the hang of it eventually. So you're not alone if you find this question difficult. Question 20 says the table shows some values of x and y that satisfy the equation y equals a cos x plus b. Okay, and on the table we have values for x and values for y. Find the value of y when x equals 45. Okay, So here we're given the equation y equals a cos x plus b, and what I would say we need to start with is finding a and b using these values in the table. And we're given lots and lots of values, so we will be able to find a and b using those. So be intelligent here, pick the easy ones, the ones that you know the answers to. So I know cos of 0 degrees, the cosine of 0 degrees off the top of my head. And I know the cosine of 90 degrees off the top of my head. So I'm going to use those two values to plug into this equation. So we can start off with, if we use 0 and 3, so we could say using 0, 3 equals a cosine 0 plus b. And the cosine of 0 is 1, so a times 1 plus b. So therefore, essentially a plus b equals 3. So that's my first equation. I don't know what a and b equals yet, but I'm going to find out very soon. So the next one I said I'm going to use is 90 and 1. So using 91, 0.91, 1 equals a cosine 90 plus b. Now the cosine 90 is actually 0. So this all becomes 0, and essentially what I end up with is b equals 1. So if we know that b equals 1, remember we know that a plus b equals 3, so therefore a must equal 2. So now we know a and b. So y equals 2 cos x plus 1. We can find y when x equals 45. So y will equal 2 cosine of 45 plus 1. And there are some very useful trigonometric values that you can remember with these triangles. So there are two triangles, one is 30 and 60 and the other one is 45 degrees. Hopefully you have seen this before. And what this essentially helps you to do is to remember the cosine and sine of 45, because if you also remember SOHCAHTOA, you know that the cosine equals the adjacent over the hypotenuse. So this tells us that the cosine of 45 is 1 over root 2. So cosine of 45 is 1 over root 2, which actually is the same thing as root 2 over 2. And that's a good thing to memorize as well. So I know, because I remember that triangle and those values, I know that the cosine of 45 is root 2 on 2 plus 1, and therefore y equals, now the 2's cancel out there, so y equals 1 plus root 2. And that's done. So question 21 says, show that 6 minus root 8 can be over root 2 minus 1 can be written in the form a plus b square root of 2, where a and b are integers. Okay. This, I'm not sure if this is a new topic in this year's GCSEs or not, but when you see a square root or a radical sign on the denominator, you know you need to use conjugates. And if you have not done conjugates before, look that word up and do some practice on this topic. But so the conjugate is when we multiply this fraction by the conjugate in order to get rid of the square root in the denominator. And essentially in mathematics, generally it's seen as easier if we can work with numbers without square roots in the denominator for various reasons. So let's go ahead and start working this out. So if we multiply that by the conjugate, what the conjugate is the basically kind of like the inverse of these numbers down here, in order to simplify that bottom line. So the conjugate of root 2 minus 1 is root 2 plus 1. And let's go ahead and start working this out and you'll see what happens. So essentially what this is like expanding double brackets. So let's go ahead and expand the top line. So we've got 6 square root 2 minus root 8 root 2 plus 6 minus root 8. And this question also deals with surds, which is another difficult topic. Let's go ahead and expand the bottom line. So the square root of 2 times the square root of 2 becomes just 2. And then what we end up with is minus root 2 plus root 2. And then minus 1. So you can see here the whole purpose of this multiplying by the conjugate is to get rid of this square root, because we get a minus root 2 and a plus root 2 and they cancel out. So then we're left with 2 minus 1 on the bottom line, which is just 1. So effectively we can cancel out that whole bottom line and we can focus on this top line here. So we've got 6 root 2, and then if you're confident with your surds, you know that we can essentially multiply these numbers in here and we get the square root of 16 plus 6 and then the square root of 8. And now here's another tricky step, because we know that there needs to be a square root of 2 in the final answer, and there's a way we can rearrange the square root of 8 to get it in the form of a square root 2. So we can split it into the square root of 4 times the square root of 2. Okay, so then we end up with 6 square root 2 minus the square root of 16 is 4, plus 6 minus square root of 4 is 2 root 2. And then, well, let's simplify a little bit more. So minus 4 plus 6 is 2. Minus 4 plus 6 is 2. And then we've got a plus 6 root 2 minus 2 root 2. And we can factorize that part of the equation. So if we take the square root of 2 out of both of these terms, we're left with 6 minus 2 in the end. And then we can simplify these terms. So 6 lots of square root 2 minus 2 lots of square root 2, well, that's just going to be 4 lots of square root 2. And what we end up with is an equation in the form of a plus b square root 2. So a equals 2 and b equals 4. And we have answered the question. Okay, question 22 says the two triangles in the diagram are similar. So here we've got ACD and ABE, these two triangles here. There are two possible values of x. Here's x. Work out each of these values. State any assumptions you make in your working. Okay, so we're told they're similar. So we know, what we know about similar triangles is that all of the angles are the same and all of the sides are in the same ratio. Now, when it says there are two possible values of x, x being this distance here, initially that might seem confusing, because how can you have two values for one length? But the trick here is to see that we don't know the orientation of these triangles. And what I mean by that is, let me just draw them separately. Angle ABE, the smaller one, ABE, could be flipped around. So let's have a look at some angles. This angle in here, ABE, that could be the same as angle ACD, or it could be the same as angle CDA. And I hope that makes sense. Essentially what I'm saying is this triangle, this ABE, could be flipped over. It could still be similar, but not similar in the way that you automatically assume it to be. Okay, so angle ACD, sorry, triangle ACD is up here as well. Okay, so there's two ways that we can find the length for x. So we can find if this side, so there's two possibilities. We can have side AE is similar to side AD, or AE, I should say related to, not similar to, related, or AE related to AC, this one up here. So this side is related to this side. And they're my two assumptions that I'm going to make. Okay? Assumptions. Okay. So if AE is related to AD, therefore the scale factor is going to be AD divided by AE, which is 15 divided by 12, which is 1 1/4 essentially, 1 1/4. Or 1.25, whichever you find easier to understand. Okay, so hopefully we're all on the same page right now. So we've got two similar triangles and we're not sure the orientation that they're in. So we're saying this side, this smaller side here, AE, could be related to AD, or it could be related to AC. And then scale factor for 2, in case that the second assumption is correct, then the scale factor is AC on AE, which is the same thing as AD on AB. So this side over AB there. So that equals 15 on 8. And that is a little bit more difficult because that's 7/8, 1 7/8. So you can see we're probably going to have to do some calculating here. Now, we've got two scale factors. So this side, AB, could be enlarged to AC, or AE could be enlarged to AC. So AC is 8 plus x. So in the case of my first assumption, if AE is related to AD, then we need to enlarge AB by the scale factor 1 1/4 to get AC. So essentially, 8 times 1.25 is going to be equal to 8 plus x. So for this one we need to solve for x. So 8 times 1 1/4, that is 10. And then 10, so 10 equals 8 plus x. So therefore x equals 2, 10 to the minus 8 centimeters. So that's if the first assumption is true. x equals 2 centimeters. Then if the second assumption is true, what we're doing is taking AE and enlarging it by the scale factor 1 7/8. Okay, so we'd say that 8 plus x equals 12 times 1 7/8. It might actually be easier just to leave it as 15 over 8. 15 over 8, because then what we can do is we can simplify, divide by 3, not divide by 4, not 3. Okay, so we've got 8 plus x equal to 45 on 2, 45 on 2, and then x equals, so that's going to be 22.5 minus 8 will be 14.5. Okay, so the two possible answers for x, there are 2 centimeters and 4.5 centimeters. I say that is worth a good 5 marks, or even could be 6 marks. But in my answer, I started off with the assumptions. I said I could assume AE is related to AD, or A is related to AC. And maybe that's not the best way to state those assumptions. Maybe there's an easier way to state that. But then I went ahead and using those assumptions came up with my 2 answers. Okay. So question 23, the last question in this paper, says here is a rectangle and a right angle triangle. All measurements are in centimeters. The area of the rectangle is greater than the area of the triangle. Find the set of possible values of x. Okay, so the only relationship we're given here is that the area of the rectangle is greater than the area of the triangle. Okay, so we know that the area of a rectangle is going to be 3x minus 2 times x minus 1, the length times the width. And we know that the area of the triangle is the base times the height divided by 2. Base times the height divided by 2. Which essentially is just x squared. Okay, and we're told that the area of the rectangle is greater than the area of the triangle. Okay, so let's write that relationship down. So 3x minus 2x minus 1 is greater than x squared. And then we can essentially solve this as we would an equation to start off with, or simplify it as we would an equation. So let's start off by expanding these brackets using FOIL. So firsts, outers, inners, lasts is greater than x squared. And then bring that x squared over to the side. So 3x squared minus x squared, that would be 2x squared minus 5x plus 2 is greater than 0. Once you get to that point, actually we can simplify further and factorize this again. So factorize this back into 2 brackets once we've got that x squared out of the way, and this becomes 2x and x, 2x and x, and then we need 2 factors of 2. Well, the only thing they could be is 2 and 1, and they need to equal minus 5x, so they must be both negatives. Okay, so once you get to this point, this is another stage of understanding where essentially you need to know how to work out quadratics with inequalities. And the first thing you need to do is to work out the critical values. And essentially what critical values are is the x-intercepts, or the solutions to this equation. So if this was an equation, the solutions are when x equals 0. So when the equation equals 0. So that's when x equals half. So you take this bracket, make it equal to 0, and find a solution to x, and then do the same thing for the other bracket, and you get your critical values of x equals a half and x equals 2. Now if you want to picture this as to what is going on, you know that this is a quadratic, and you know that it's a positive quadratic, so it must be an upwards facing quadratic, a smiley face. And what these critical values are is where the quadratic cuts the x-axis. So essentially when that quadratic is cutting the x-axis at a half and 2, it'll look something like that. And so we need the values of x when this equation is greater than 0. So when this curve is above the x-axis. And you can see in this image, when the curve is above the x-axis, it's when x is less than a half, and when x is greater than 0. So this part of the curve. All of this in here, between these two values, is when this equation is less than 0. So we don't want to worry about those. We just care about the values above the x-axis when this equation is greater than 0. So what we need to do is say, well, x could be less than a half, or x could be greater than 2. But this is where you need to go back to the original problem, and if x equals a half, essentially this becomes a half minus 1, and that will become a negative value, and you can't have a negative width in area problems. This is not possible. So therefore, this is not possible, so therefore x must be greater than 2, and they're your possible values, or that's the set of possible values for x. And that is the end of the paper. That is a total of 80 marks for that paper. So if you've had a go and you've been marking it, you can go ahead and total your marks up. Let me know how you did in this paper if you did have a go. But overall, I hope you found that useful, and I'll see you in the next video. I'll be doing paper 2 next, so stay tuned for that. And I hope you leave a like if you found this useful, and leave a comment letting me know what you think. Thank you very much for watching. See you next time. Bye.